So we're going to start looking now at things other than just base 10. Everything's been a power of 10, or the big number, excuse me, has been a 10. Now how about some other numbers? So do you agree with each statement, true or false? Just a reminder that this is a less than symbol. So do you agree that 3 to the 5th is less than 4 to the 6th? True or false? So if I multiply 3 5s together, will that be less than 6 4s?
Yes.
Why?
Because 3 to the power of 5 is 243, but 4 to the power of 6 is 4,000.
Yeah, you certainly could figure it out. The base is smaller and the exponent's smaller, so that's definitely going to be a smaller number. But yes, you could always check it as well. Okay, how about number 2? Is negative 3 twice is less than 3 twice? And again, you always could write it out, right? I have negative 3 twice. Is that less than 3 twice? Sienna, what do you think? Okay, wait, what's negative 3 times negative 3? Yeah, they are equal, right? 2 negatives, if I multiply it, is a positive. So I get 9 equals 9, which would make our initial statement false. Okay, 3. Negative 3 times negative 3 times negative 3 equals 3 times 3 times 3. True or false? Yeah, that one is false. If I multiply 3 negatives together, I do get a negative, right? Odd number of negative signs. That would be negative 27, in fact. The right side would be positive 27. Those are not equal. All right, question number 4. Put a little star by this one. This is a very common mistake. People think that those are the exact same thing. Okay? On the left side, it does mean negative 5 twice, which is, of course, 25. On the right side, though, because there are no parentheses, I got to follow the order of operations. It's 5 squared, and then a negative sign in front of that answer. Okay, so 5 squared is, of course, 25. That negative sign gets put in at the end. So that statement would be true. But those two notations are not the same answer. Okay, so put a little star by that because you will see that going forward. And that is a common mistake. All right. What happens with 0 and negative exponents? We've done a chart like this already. Now we're looking at one here. With powers of 2. Same exact chart, I think, other than that, from the looks of it. It says, as you move towards the left, each number is being multiplied by 2. What multiplier would be as you move to the right? So what multiplier would be used? What is the opposite of multiplying by 2? Opposite of multiplying by 2 is? Dividing by 2, or multiplying by? Times a half. So that's my multiplier going to the right. Okay, so let's fill it out. We can just start here if you want. We're multiplying by 2 going this way, so I'm going to divide by 2 going this way. So 16 divided by 2, 8, which is 2 to the 3rd. Divide by 2, 4, which is 2 squared. Divide by 2, 2, which is 2 to the 1st. Divide by 2, 1, which is 2 to the 0. Anything to 0 power, remember, is 1. 1 divided by 2 is a half, which is 2 to the negative 1. 1/2 divided by 2, 1/4, which is 2 to the negative 2. 1/4 divided by 2 is 1/8, which is 2 to the negative 3rd. 1/8 divided by 2, 1/16, which is 2 to the negative 4. All right, use that pattern to find out 2 to the negative 6. Okay, remember that 2 to the negative 6 is the same as 1 over 2 to the 6, which is 1 over, so 16 times 2 times 2. 16 times 2, Parker, times 2. Perfect. 1 over 64. Okay, so if 2 to the negative 6 was 1 over 64, what do you think 1 over 32 is? Yeah, we passed that one getting to 6, so that is negative 5. Layton, what's 2 to the 0? Look at the chart. Yeah, anything to the 0 power, remember, is 1, no matter what it is. From the work you have done with negative exponents, how would you write 5 to the negative 3 as a fraction? One over what? Negative exponent goes to the denominator, right? 5 times 5 times 5. 125. 3 to the negative 4, same thing. 1 over 3 to the 4th, which is 1 over 3 times 3 times 3 times 3. 81. All right, just want to make note then, if you ever would see a fraction like you see on the Are You Ready there, 2 over 3 to the negative 3, again, it would go in the denominator. And the opposite of dividing by 2/3 is multiplying by 3 over 2. So the pattern, if you ever see a fraction, you can simply flip it over, make it positive. So it gives us one on number 2 there, next page. So the pattern, if I have a fraction and a negative exponent, flip it over, make it positive. Just leave it like that. All right, let's move on to number 3. Lynn, Noah, Diego, and Elena decide to test each other's knowledge of exponents with bases other than 10. They chose an expression to start with, came up with a new list. Some are equivalent, some are not. Choose 2 lists to analyze. For each list of expressions you choose, analyze decides expressions are not equivalent and be prepared to explain. So there are 4 of them. I'd like you to do 2 of them. Circle the ones that are equal. So like the first one, 5 to the negative 9, which ones of these are going to equal 5 to the negative 9 is the question. So let's have 4, 5, 6, 7, 8. Ian, you'll be included with this half. Why don't you guys do 1 and 3? Answer those. The rest of you do 2 and 4. You can do it alone still. Circle the ones that are equal to that. So E and 1 and 3, Parker, you got 2 and 4. All right, everybody get a chance to answer? You know, spokesman for number 1. I guess I circled the ones that are not equivalent, so I have 3 that are not, so that means 3 of them are. Anybody think they got one? Y'all that had 1. Ian. Okay, are you circling the ones that are not or the ones that are? Not. Okay, you actually read the directions then. Not. 5 to the 9 with a negative in front. That is accurate. That one is not the same. Somebody else have one for number 1. Which one? 4th one. 3 times the negative 2 is not negative 9. And one more. The last one. Add those together. Negative 4 plus negative 5 actually is negative 9. That one's fine. It's this one. Negative 4 minus a negative 5. Remember, if you have 2 negatives, it turns into a plus. There it is. Okay, question number 2. Somebody from this side of the room. The ones that are not equivalent. I have 2 that don't work. Lucas.
The first one.
The first one, 5 plus 2 is 7. Somebody else, another one. Nobody on this side of the room has another one besides Lucas. All right, Lucas, you're the man.
The last one.
Yeah, 20 minus 2 is not 10. Okay, question number 3, back to the left side, x to the 4th. I have 2 again. Bethany.
4 times x.
4 times x is definitely not the same as x to the 4th. One more. 4th one. Negative 4 minus another 8 is negative 12. That doesn't work either. Fourth one, 8 to the 0. Which one does not equal? Right side of the room here. My right, not named Lucas. I need somebody to give me one. Ian, that's not even your problem. Gabby? Not the last one. Remember, anything to 0 power is 1. Third one would be 8 to the 0. That one's fine. 0. Anything to the 0 power is 1. Well, 0 doesn't equal 1. That is the one right there. Okay, in the summary there, kind of a good explanation again of a review of things we've talked about. When to add, when to subtract, when to multiply. Important to know. There are a lot of those going forward. Your assignment then is just 1 through 4. 1 through 4 for tomorrow.